Okay, hello everybody, and welcome to my talk on using Conan in a real-world complex project. My name is Kristian Jerpetjøn. I have experience from working in Kongsberg, Aker, Thales, and IncludeOS. My background is primarily a programmer, but I also worked on a lot of build systems during that time. So a little background for this, I was hired to port IncludeOS from x86 to 64 to also run on ARch64 architectures after NDC last year. Kind of convenient. IncludeOS is an open source modern C++ library operating system, for those of you who don't know that. And it went bankrupt in June this year. So kind of sad story, but it's open source, so please contribute to keep it alive if you have the option to do so. So what I'll be presenting here today is why we introduced the package manager in IncludeOS, Conan and some basic features in Conan, Conan inside IncludeOS, and hopefully some demos. Actually, there will likely be quite a lot of them. And some tips and tricks based on our experience working with Conan. So let's start. Why introduce a package manager in IncludeOS? So often a question, why would you do anything with something that's already there? So basically I'm going to go through what we had in IncludeOS, which was we had dependencies built outside the CI system. So we can start there. Anyone seen stuff like that before? We had some Git submodules. I don't know if you guys like them. I don't prefer them at all. Lots of complex SeeMake for handling these dependencies and pulling in things. Some environment variables were needed to get things put into place on an operating system level. Lots of bash scripts to install things and move things around and compile some of the dependencies, but not all of them. Didn't always work. It couldn't build out of tree because it had dependencies internally. And even sometimes when you built it, it would fail if you had a fast enough computer. So that's why I say, why change this? It worked, right? Well, there are quite a few reasons why you would want to change this. We needed to port across architectures. So if you look at the above list, imagine walking through all of that and trying to add another architecture to it and make it stable. You introduce a lot of complexity to it. You also have the maintainability of what you have. As I said, the above was already complex, and you need to look at, can you make it any better? And also, it wasn't reliable. So you could build it, it would fail, and then you would try 3-4 times, and then it will work. Reason being quite simple, when you do the SeeMake's external project thing, it'll pull something down compile time, and if you link to that, you'll get a timing issue, and it doesn't really work well. So that was a lot of the reasoning why we wanted to change it, and also to improve user experience, which is mainly, I think, the biggest value of changing to Conan. So why Conan? Well, I had a lot of different options. I'm not going to go through them, probably more than those. I'm not an expert on any of them. I can say that straight out. But we did take a few things into consideration looking at what we needed was some kind of artifactory bin tray sort of integration. We wanted something with good traction, having a close relationship with Diego in Conan. We sort of had the know-how of where it's going and what they're working on, and we can monitor the project. SeeMake was important for us because we already had tons of SeeMake, and if it doesn't integrate well with that, you're basically starting with something new. And also, history-wise, what's the history of this package manager? And in Conan's case, it's sort of started off as an open source, but they were bought in by the JFrog team, so they're in that sphere working with Artifactory and sort of like integrated. And also the community around it, they have their own channel on CPP Lang, Slack, and you can discuss with them and get help, and there are also other channels using them, so that's important as well. And as I said, it's obvious we went from Conan based on the talk here, but there might be others that can do the same. So let's start with Conan. What is Conan? They say themselves it's a binary C++ package manager. What does that mean? Anybody want to try to give a clue of what that actually means?
It holds compiled artifacts rather than source code.
Yeah, that's one way of interpreting it. Yeah. So they're also claim, this is their statement, the open source decentralized multi-platform package manager to create and share your native binaries. There are a few things there that I picked up on, is that, well, this is incorrect, and a few other things as well. It doesn't need to be limited to compiled C++ code either. I would maybe phrase it something like this after working with it for 6-7 months. An open source decentralized way to build, distribute, and consume binary packages and recipes across platforms. Because you can cross-platform them. They don't have to be native. But that's just my interpretation of that sentence. So getting started with Conan, very simple. If you have pip, you install it by pip. If you have a distribution that has a proper package for it, you can install it that way. The Windows part, I'm not going to go into on this talk. I'll leave it completely out, but I know it works on Windows as well. So using the Conan help command, you get this list out, which the various commands you can use in Conan. And you got some consumer commands, which is for the end users. And then you have the creator commands that are for people creating Conan packages. And then you have the tools to work on the created packages. So I'm not going to go through every single one of them, but there are quite a few you normally run into. And that is, you'll run into the profile, which is the most important key in Conan, which is the markup of how your compiler configuration and package configuration is, like what tooling are you building for. You have the install command as a consumer that basically installs a list of packages into your current directory or wherever you want to. Also you have the create command, which is normally used by the CI system to create an actual package. You do want to do it internally from time to time, but it's mostly a CI command. You have the build you can use, and then you have the editable, which I'm going to get back to, which is probably one of the hardest things to get right in Conan. And of course, you got the remotes, like pretty much like Git remotes. You say, where are my repositories and how am I going to work with them? You have the search to search. You have the info to get information about your dependencies. So it's a lot of packages, a lot of commands you can use to work on the packages from different locations. My suggestion is if you start with this, start small. If you go full out, well, take your time, because it takes some time to get to know this. So some of the control files Conan uses, they have a Conan file py, which is mainly for a package you want to, I would say, a package you want to give out to someone, like so somebody can consume it. That's when you will write a Conan file py, which is an explanation on how you build this source code, how you deploy it, and how you consume it, and what dependencies does it have. Everything goes into a Conan file py. Conan file text is more of a consumer level, where you say which Conan file packages, which Conan packages am I consuming in this project. So they are sort of a link between these two, because you can have a project where you have both a Conan file py and a Conan file text, because you want to use that package just as it is, or you want to use that package in another project again, in which case it's better to just go with the Conan file py. You have the layout text, which is for editing packages in editable mode. You have a YAML file saying what you're allowed to say, like, can I use this compiler? Let's say you bring down a brand new compiler and Conan doesn't really support it, you can add it there. So that's control parameters, and you got the profiles, which defines which tool chains you're using, the target architecture, and also you can define dependencies in profiles. So let's go through these. So you have the Conan file text. So this one is requires is one statement, which is where you're telling what packages are going into my component, as the sense that I'm actually linking them into my component. And build requires are what tools do I need to build my component. And you have this fancy syntax here. Take note that this will try to use any package newer than this version. And the reason I do the include pre-release is that semantic versioning in Conan will not get triggered before you reach a 1.0 unless you put that keyword in. And then you have a user and a channel, which sort of like a Git branch is a nice comparison to that. So you can have different branches in Conan. So you can have the latest branch, and then you can have a stable branch, which was what we did in this case. So this package here, this is from our Hello World example. It says I'm going to need IncludeOS. It's going to be newer than this version. Don't really care which one. And please pick it from IncludeOS latest and not the stable. And the same with the chain loader, which is a tool to boot it up. But the VM runner, which is a different tool, I'm saying I want this fixed version into my consumer. VM build the same. And then you have the generators, which is the virtual environment generator and the SeeMake generator, which is the ones we're using in this case. So that's an example on how a Conan file text can look like. Conan file py, however, we start getting more complicated. That's Python. Not everybody likes Python, but it's a tool. And you start by explaining, hey, I have my package, and it's subclassed on the Conan file. I say what name it is, what version it is. Of course, you'll say a lot more, but this is the minimum you can do. And then you have a function to say, hey, I'm going to fetch my source code, a function to say I'm going to build this source code, and a function saying I'm going to package this source code. You also have a lot of other options here. You have options to sort of add additional configuration to this, but I'm not going to go into it right now. What is important, though, when you look at this, is that this looks like a class, but it isn't. Because Conan parses this and finds your functions and call your functions based on the command you give. So you can't really set a variable here and expect it to change here. So the way you should be interpreted is as 3 separate classes. So you'll have one where you source, one where you build, and one where you package, just to get your head around that, to avoid stepping into the faults you can get. And this is taken from the Bingcrafters guys, because they made this very nicely for me, so I could just use it to sort of try to explain it. But it's important to look at it this way, because you run into a lot of faults if you try to change variables in between these methods. So, Conan file py. You can do different things. You can have a Conan file py, this one, which I will open up, which actually uses this one. So you can have inheritance between them. I would not recommend it to start with, but at a certain point you might want to reuse methods and get some dry into your Conan files. at which point you would need this. So I'm just jump around a bit here. So in this, just get my head in place. Give me a second. Yeah. So this is our IncludeOS Conan file pi. So this covers a lot more ground than my very small example did. Here we're using the feature from Conan, which is Python requires, where I'm telling Conan that I actually need this package to use this package. And it'll download this and use it into my tooling, so I can use the Conan tools get semantic versioning, which is a generator to actually just from my current git tag and commits after the git tag, it generates a semantic versioning number, which is convenient to avoid having to type it in every time, so you can leave the Conan files untouched once you have them right. Cover your license, the generator, SeeMake and virtualenv, URL, and then you got this part called SEM, which I'm telling Conan that this is Git, so when I build, I want you to fill out whatever Git tag I'm building from and all of the remotes, etc., so that it can be reproduced later. Then we have another field here called options. Options are a way in Conan to have alternate behavior on a package. Options to, let's say, leave out OpenSSL, include this. You can sort of like, you get where I'm going from C++ perspective and packages in general, that you control them with options. Conan does require you to put a default options so that the platform in IncludeOS is default, SMP is default off, and that's our basic options. Then you got the no copy source true, where you're telling Conan that we're actually not going to copy all the source code because we're doing SeeMake, so we're building out trees, so it doesn't make sense to copy the source code around. Then we go into requirements, which is the same as the requires part of the Conan file text in behavior, where I'm telling that I need GSL, because we're using GSL. If we are in user space, we're basically building native application. We don't need to build in our custom-built CXX libraries. If it's ARMv8, I need this additional package. If the platform is not nano, I also need these tools into my system, or these libraries into the system. If I'm building with the Solo 5 HVT, Solo 5 HVT is IBM's version of Firecracker, basically. It's a super small virtual machine that will run isolated by itself with the minimum API you can do. And it needs to run with GCC, because the IBM guy says, don't use anything else. So if your compiler is not GCC, then you get an invalid configuration warning from Conan, which is why I included the invalid configuration part here from Conan. Also, I included Python requires as I needed here, SeeMake as I'm using further down, and Conan file is of course always needed. Then you got the configure part, which is the next part here. So you got the requirements, which is get your requirements part right. Configure is run like prior to building. It's sort of part of getting your checksum calculated. So I'm saying that do all of this, but actually exclude which CXX which CXX library I'm using. So that will not be part of my checksumming, and you can do all of this magic, but it's really hard to get it right. So start by doing something simple and then go on. Then you got the target architecture you can go through. You can define your own functions, because the functions will be on class level, but the Conan functions that Conan are searching for inside the methods, those are the functional parts. So you got the build step, because we got the source already, that's the SEM. The build step will run the configure SeeMake that will use the options I put in to get some SeeMake variables set right, and then return the SeeMake where I call SeeMake build. And as you see here, once I get to the package step, I have to do it again because of the functional thing. There's nothing left in between. And then I run SeeMake install. At the package step, you can also manually copy every single .a file where you want, every single .h file where you want, but fix your SeeMake install. That's a lot easier. And then you got the package info, which is a bit hacky some places, but it's fine. This one is quite self-explanatory. I did this trick to get the SeeMake part of my package available for the consumer. I'm adding my include directories to say this is going to be available for you, which is outside, because the default is lib is available, include is available, but if you have something outside of that scope, you should add it in here to make sure the consumer can consume it. It also affects how the generators will generate SeeMake code and all of that. And then we got some more Python magic here to get the right library names out. So when you consume it, you say, hey, this is my architecture, and they give you a library name based on your architecture. Probably a bad design, but we didn't want to change it. Then you got some, with the CPP info libs, I'm telling which libraries in this package are you going to consume if you use my package. And I'm also telling where are these packages, because they can be in two different structures. So you're kind of explaining, like, this is how my package looks like in a generic way so a consumer can consume it. And then you have the deploy step, which basically, if you do a deploy, you take the Conan package and deploy it to your file system in a given structure. So this is nice if you want to generate another type of package. Let's say you want to put it inside a Debian package or whatever, you can use this. It's a feature. So that was a quite short but intensive round of the Conan file pie. Not sure if you got anything out of it, but hopefully you did. So let's get back to our slides here. Yeah, of course you couldn't figure out where it was. I'm gonna sort that next time. Whoa. Yeah, I need to fix my presentation style. This is gonna take a while. Sorry for that. Yeah, so we were there. That took forever. Slide 12. Then you have the Conan profile. Well, I'm not going to use the console this time. Conan profile on this system for IncludeOS is actually, I'm building for a Linux system on a Mac OS. So I'm cross-compiling. My architecture is still the same, but I'm cross-compiling. I'm telling which compiler I'm using, the version, which lib C++ I'm using, the C++ standard I want to have, and the build type. I'm also setting up my compiler optimizations and all of that in my profile, which is one way of doing it. And I'm also saying that every single package I'm building with this profile, I want my bin utils to be available for. So you can sort of like add your global dependencies here. You could potentially do, I've seen examples where they do the whole tool chain this way. So you put the whole tool chain in this way and just ignore it everywhere else. Conan has a lot of generators. You got SeeMake, SeeMake multi, paths, find package, yeah, tons of stuff, Visual Studio, Xcode, GCC, even got a text version or an JSON version. So if you want to take a generator and fix it into your custom system, you can actually just create that in Conan. But in IncludeOS, we only use SeeMake and virtual environment. Pretty much enough. And that's for now. Might change in the future. Yeah. So when you start working with Conan, the first thing you do is you add some repositories you need. We have the bin tray repository. Yeah, this one is the wrong copy. No, it's not. We have the IncludeOS repo on bin tray, and you have the Conan repo on bin tray. So this is our custom packages, and this is external packages in our case. Of course, if you're running this in a closed environment, you need to fix this yourself. Fortunately, Conan actually has an internal server you can run up, so you don't have to necessarily install Artifactory. You can actually just run that server. But if you want to investigate and work with it, you should probably install it. Yeah. Conan SeeMake is a separate tool that Conan provides. It allows you to wrap Conan commands inside of SeeMake. We started off by doing it and went away from it because of a usability point of view. But as you start, if you already have a SeeMake project, you might want to use this just to get that one package in and get started working on it. As you can see here, you can directly quote which package you want to include, or you can have a Conan file and have it include all those packages for you. Both are equally valuable. So let's go over to IncludeOS. This is gonna get some heavy stuff here coming, I think. No. Basically, as I said, we had a binary bundle built outside the CI system initially. So as a proof of concept, we took that binary blob and replaced it with the Conan package. It's essentially still the same blob, we just put it inside the Conan package. So we replaced the SeeMake external project with a Conan SeeMake run command, and that was it. What happened was that by doing this, when we run the SeeMake command, the dependencies downloaded at configure time, as opposed to SeeMake external project where it actually gets run in as you're running it. And the real work was to create Conan packages for all of these dependencies. The rapid JSON, GSL, HTTP parser. Some of these are header-only dependencies. You might say it's a bit of a stretch to put that into a package, but it's kind of convenient, because then you actually know which version you're consuming and you get all the traction in order. The hardest ones here are probably like musl and libc and all of these, to get them right. Also, we went into the unit testing and created Conan file text for what are the dependencies for the unit testing. And our dependencies for the unit testing, once we got them in, we fixed out-of-tree builds, because suddenly we could move our unit tests around and run them where we wanted, because it was isolated away. Refactoring-wise, we moved all libraries that weren't part of what we call the core operating system out from the operating system and into individual Conan packages. So they all got their own Conan file pie, and they all got their own versions. And in addition to that, we moved all our tooling into Conan packages. So all our tools that were downloaded from different locations and compiled and installed into some prefix and /bin or whatever, all of them got their own Conan file pie and a version number and put into the CI system as well. And the next step was, we now had a system where we had IncludeOS was building as a library from Conan, but it wasn't really deployed for the consumers yet. So we figured out, well, let's use Conan install with a Conan file text to get your IncludeOS environment in place. So by doing that, we generated Conan build info SeeMake. We added a nice, based on the Conan build info SeeMake, we got the paths right, so we could do an IncludeOS inside the SeeMake, where we put all our fancy functions that we needed. And also we added the Conan file text for every single example and started using it in our integration tests as well. And this is part of the usability factor when it takes 5 minutes on a clean system to download all your dependencies and build an IncludeOS VM and run it up. And you also get a full dependency graph, so it's kind of it's a nice feature. So it's demo time. Let's see if I can get this demo up and running. So here we have our Hello World example. I'm actually going to show it in code because it's easier to look at. So we have our Hello World where we have a Conan file text, which I showed you earlier. Played a little bit around with it, doesn't really matter. And we have a SeeMake. So this is our SeeMake for building a virtual machine, doing a Hello World. And we do the operating system add executable. It's to wrap the internal things in SeeMake. It could maybe be done otherwise, but it's kind of a convenience way to have a slightly look and feel like a normal executable, but we're expressing that you're doing something else than a normal executable. So this include Conan building for SeeMake will give me all my dependencies, all my libraries, and everything in order with respect to that. And Conan basic setup is just configuring that part for me. IncludeOS includes os.seemake, which is a self-made file that's part of the operating system. And then you have I want to add this executable, and I want to add a default std out, which is a library we have. You could also add additional drivers to it, but in this case, we can get away with only this. So the main for this program is very big. It's not the hardest thing to get. And we provided a VM for it and a Jenkins file that will actually build it. So for every release we have of IncludeOS, we get a test build that, yes, this application still links. So in case we mess something up, which of course did happen. So let's see if we can get it running. So first I'm going to check if my remotes are in order. They're not. No, it's a list, sorry. So I got the IncludeOS repo here.
Make your font a little bit bigger.
Oh yeah, sorry. Let's see, that helps? Is it okay in the back? So I got the IncludeOS repository set up in Conan here. So let's say I'll just, as you saw there, it's an empty, so I'll make a build folder. And then in my build folder, I will do, for remembrance, I'll do Conan profile list. Just show me what profiles I have available. And you see here we have a profile for Apple Clang 10, which is when I build something needed to execute locally. And I have a Clang 6.0 macOS, which was when I want to compile something to be run as a Linux elf. And then I do a Conan install, and you saw the Conan file earlier of .out, which is where the Conan file is. And with the profile, Clang macOS. So let's scroll to this because it did a lot. It did it fast because it's all locally cached. Let's say where it goes in. So it starts by listing, hey, this is the tools you used, and if you didn't specify anything, it'll just do some guessworking. This is the environment you wanted. There's a warning here that some of the requirements are not in sync. So Conan will tell you if you have one package that depends on something and another package that depends on something and the versioning is not correct, it'll complain. This is because Conan is built for static linking, so it's kind of want to warn you that, hey, you can't really do this. It does override it. Tons of warning here. And the version range is resolved to this. So every time it needs to resolve one of these, you get a warning on it. Then it goes to installing the packages. This is the requirements for IncludeOS. And they're all in my cache. This is summing up the packages once more. This is the tools needed to build it. And this, of course, comes from my toolchain file, because I didn't specify anywhere I needed this. But my toolchain, my profile, is telling me I need this. So that's why it's pulling it in. Then you have Crossbuild. So it detects that I'm cross-building. And just apply all of this. So what did it do? Let's skip back to Adam here for a second. So in my build folder, we got a activate sh, a Conan lock, a Conan build info.seemake, a build info.text, graph info JSON. So let's have a look at this slightly fastly here. It's my wife's computer, that's why her name is there, interestingly enough. I don't ever want to own a Mac, that's why, I'm just joking. And if you scroll down here, you see it generated quite a lot of SeeMake for me. About compilers, tools, everything. And they're all pointing, you see it's pointing to the directories where all the directories are in my cache. They're not local. Let's see, what's the other thing we want to see here? Yeah, you got the build-in for text, which is sort of like a textual explanation. This can be parsed by any tool, so it's kind of easy to work with. And you got the info as well, which is like what options have been used here to build this, which is sort of needed. And then you have the activate and deactivate. That's my virtual env generator that's generating those. So in my activate, I'll get, kind of nice, I'll get something added to my Python path, something added to my path, and some local variables that are defined by packages. So a package can actually say that if you consume me, then I'll set this environment variable to this, which is a convenient way to sort of express what you want to do. So what we can do then on a Mac is we can source activate.sh. So what basically happened there is I got my CC variable set right. And of course I haven't run SeeMake yet, so I can do the SeeMake ... I'm going to run SeeMake. So how does SeeMake work in this case? Because SeeMake will default to try and build and execute a binary. I haven't specified to SeeMake I'm cross-compiling, but I have specified to SeeMake that I don't want to test anything other than compiling a library. So sort of getting away with it without doing a full cross-compiler. Then you get all these library found. So it found operating system, architecture, all of these. It found all my libraries. So that's good. So let's see if we can build it. So yeah, so we built the target hello. That's nice. Didn't take a lot of time. You can look at it. And the hello app is about 1.4 megabytes. And then we can boot. So boot is a tool that's provided by VM runners. That's now in my path as well. I can boot hello. Of course, it's a password. It's normally the way when you run a VM. So the VM run up, printed hello world, and exit it. Yeah, and me and not being too much friends with Mac at the moment. Yeah. So that's an example on how you can build and run a hello world example. So that's, well, it's not that interesting. So let's see if we can get something more from this. So we do a Conan info on the package with the right profile. I think that's needed. We might just try Conan info. Yeah, it doesn't work. So we need the profile here. So what it did now was it gives you all the information on all the packages going into this. That's convenient. Can we do something else with this? Yes, of course we can. We can use a generator to generate my dependency HTML. So, didn't get any printout, but I got a HTML file, which I think I can open in, where did it go? Did I type it? No, it should be here. Ah, yeah. So it generates this. It's a big file. Need to open it with something else. Is this the correct command? Don't remember. No. It's -A, is it? Yeah.
Open work.
So, it's a nice Apple trick to get away from it. So here I have my dependencies. So you see my Conan file text is saying, hey, you need these tools, and then you need IncludeOS, which needs these libraries, which again needs this, and this, and this, and that. Which is, I think, one of the most powerful things in Conan is this is built into it. Always nice to know what you build it from. Let's see if let's see if I can return to where I am. Yeah. I don't want you up there. Sorry about this. Not a tooling expert. Yeah, I'm just going to go for it like this. So Conan Editable, on the other hand. So we covered how to run up an example program. We covered some of the Conan files going into some of the dependencies. So what about editing a package? Let's say I want to change some content in one of the packages. I want to rewrite some of the basic code. How would you go about doing that? So one way would be that I will check out the code in Git, do my changes, run the unit tests, push it to the CI, pull it back down, and then test it. Nobody wants to work that way, so nobody will. You can do a local Conan create, which is a command to create a package locally that will end up in your cache. But then you do something I like to call cache pollution. You don't want to do that either, because you end up being unsure what's in my cache. What you want to use is Conan Editable, which is a way to tell Conan that this package of this version, if somebody asks for the source files or any of these folders, go to this location. So let's see if I can do that. Let's say, need to increase the size here as well. So let's say we want to edit IncludeOS, which is like the main library. Yeah, if I can type right, it'll help. So I want to edit IncludeOS, and for convenience in IncludeOS, we created a file which is a layout, and I'll walk you through the layout first here, which is quite hard. The layout is, let's see here, yeah, skip there. Layout text file, and I need to view this as something else, otherwise I can't really understand it. So the YAML Yinya template, this is really complex. But basically what I've done is I've set simple equals true, which means my builder will be build, which is a relative path in comparison to where I set the layout file. and I'll skip all of this because actually you can have multiple build folders for architecture and stuff like that. It's kind of hard to work with mentally as well. I'll tell the bin directories I want to add is the SeeMake folder from where I'm currently standing. Include directories is the API from where I'm currently standing. The lib directories I want to expose are plugins, drivers, lib, and platform. I think all of you, or at least some of you, know that SeeMake doesn't put things into these folders. So you also need to modify your SeeMake to reflect your deployment structure when you compile things in SeeMake. Also, yeah, the resource directories, which is the current directory. This is a to-do because that's Conan workspaces. I haven't figured that one out yet, but it's sort of an even easier way to do what I'm going to do now. So first I start in the right shell, of course. Where am I? There. So first I start here in IncludeOS. I make the build folder. As I said there, I need a build folder, right? So I make a build folder, and then I do Conan editable add IncludeOS version 010 at IncludeOS. Let's call it stable. It's not going to be stable, but yeah. And then I want to add layout. And of course, it's this folder I'm adding.
You're not in the build folder.
No, I'm not in the build folder. That's correct. I'm not supposed to be in the build folder.
You create a directory.
Because what I'm telling Conan is, where do you need to go to find the Conan file pi? Where is the mapping between the Conan file pi and location of the folders? So this is a command towards Conan internally. And most of the Conan commands can be called outside of source. You can specify it all, but the commands become really complicated. So now it's saying, well, you're not allowed to put this in, because according to your Conan file pi, your target is 0.15.1-5. So what happened was Conan ran my semantic versioning thing and realized that your version should be this, and you're trying to create something else. That's not okay. So I change it to match that, which is something I can do. That should be correct. Oh, yeah. Now I get an editable, whatever that means, right? So I can do a Conan editable list and see that, yes, I have an editable, and the layout file's there, and the path where the editable is working on is inside IncludeOS. So that looks fine. What you can do to avoid like real complications that will arise from this is that when I now do a update towards the Conan repository where I'm basically saying, Conan, please give me the latest version of all your packages, I will probably get a newer package than this. In which case I should add an alias, putting it to 0.99 or something to avoid that. So let's see if we can build it. So go into the build folder, and we do Conan install .pr. Still have it in my copy? Yeah. So I'm saying to Conan, please, in my build folder, install the entire IncludeOS. So what it did was it generated an environment of all the IncludeOS dependencies. So that's nice. And then I can do a source, activate, sh, basically exactly the same. It's the same sequence all the time. You do source, activate, sh, you run your SeeMake code, and use whatever binaries you want inside there. And to get out, you source, deactivate, or close your shell. And this can also be done inside Docker images, so it's really nice. Yeah. So I can now do a SeeMake of ... Should be able to do it at least. So now I've pulled in all my current dependencies. Not the same list as you saw, it doesn't really matter. The fact is that inside my build folder I now have the ability to type make. So let's see what happens with our previous Hello World example. Because that's interesting to have a look at now. So I just remove everything in my build folder from previously. And then the Conan install, yeah, just rerun the command, it's a few steps up here. So if you scroll up here, you see something interesting on this line. When I redid the install, it detects that your IncludeOS table is in editable mode, which is a very good thing to check, because otherwise you won't see your changes. So if you don't do a new install, it won't reiterate through your dependencies and find the editable. So let's see what happens now if you source, activate SH, and again do the SeeMake ... Scroll up here, you notice something interesting. It doesn't find them. Why is that? Well, in my editable, I only ran SeeMake. I never built it. So it can't find the files there because they're not really there. So I have to, of course, compile my source code, which is the entire IncludeOS, and that'll take some time. So while we do that, I'm going to forward a little bit on the slides here, so I try to get through it. So another part of Conan is primarily, and I don't think people really understand it, it's convenient for developers, but it's even more convenient for CI people and people consuming it and DevOps. And in our case, for dependency Jenkins files, we use job DSL to automatically generate all of the build jobs to build all of our dependencies and deploy them, all of that. You can modify the Conan user home to avoid cache pollution between jobs, because you want your job to build cleanly against, against your repository and not against some other build job working on the CI node. Of course, putting things in virtual environments helps on this. In our case, we run a Conan create package on every single pull request. So we create the packages, we run the integration tests on them, but we don't deploy them unless they're successfully merged. At that point, we upload them into latest. And at the final, we upload a stable package if you tag a release. So that's a convenient part of this, is that everything sort of works together. And some tips and tricks. Yeah, we have some time for that. Start with something simple. What I showed you here today is not what I would call something simple, but it can show you where it can go. Use Python requires for inheriting generic code. Make sure your CI system package and uploads recipes and packages. Use alias when in editable to avoid new versions overriding your dependencies locally. Always verify editable packages when running Conan install. That's one of the biggest pitfalls. All of our developers ran into that even though they knew it. So it's kind of important. I can't emphasize enough how to check that. Rerun Conan install whenever you have changed the dependency. Wildcards, you have to add pre-release equals true if you're less than 1.00. Avoid pushing local versions to package repositories. That's a no. Share the code, not the package, if you're collaborating on unreleased packages. If your CI system supports it, have it create the version numbers automatically. Add the semver commit after last number tag is a convenient thing to have. Avoid having multiple packages and or recipes in the same repository. This has to do with the versioning and how you manage that. Avoid using too many options. You can get into an option nightmare in between packages. Use unset Yeah, that's a typo there. Unrequired settings. So if the compiler doesn't matter, let's say you're compiling C code, you can unset the compiler as being a dependency. You still might want to keep it, but it's up to yourself. If you need something like, hey, I need the operating system I'm building on when I'm building it, but I don't need it when I consume it, remove the fact that you need that operating system and you have one package instead of 4. So it's kind of important to think about that. Unsetting settings is a way of reducing the complexity. Do not try using Arch Target. It doesn't work in Conan. It's not specified. There are some documentation on it, but it doesn't work. They're going to fix it in 2.0. So for now, you have to hack your way around the full triple cross-compile thing. Run a local server to cache packages close to the CI. If it's a long distance to your package manager, your CI might run into problems when building your package that are not related to the code or anything in it. And some to-dos for IncludeOS is to get us into 2.0 and start using workspaces. That's the things we didn't get to do. And let's just skip back to my still building. Quite a lot of code to build. Yeah. So while that's building, probably some questions.